Soil lecture number 4, soil classification. This slide shows U.S. Department of Agriculture textural classification. So we have percentage of silt, percentage of sand, and percentage of clay in the soil material, in the soil sample. For example, soil A shows 30% sand, so sand is 30%, 40% silt, so silt, and 30% clay size particles. These three lines meet each other in this area, and therefore we can describe this soil as clay loam. That's soil A. This is called a textural classification. This is good for agricultural purposes, but it doesn't provide us with the required information needed for a construction project. Another classification system that is used for construction and engineering application is the Unified Soil Classification System. Another example of a classification system, which is mostly used for road construction, is AASHTO, American Association of State Highway and Transportation Official System. So the classification system provided by AASHTO. And then we also have another one, which is provided by OSHA, Occupational Safety and Health Administration. It's an appendix to the OSHA technical manual, and that's also another example of a soil classification system. So these three are three different examples of soil classification systems. In this lecture, we will go over USCS, Unified Soil Classification System. And in this class, we also look at classification provided by OSHA. So first, we're going to look at classification system provided by Unified Soil Classification System, or USCS. USCS provides a symbol for a soil sample. That symbol is consisted of letters. So we have a symbol. The first letter can be gravel, we use G. S if it's mostly sand. M if it's mostly silt, and C if it's mostly clay. So we need to see which one we have more. What is the percentage of gravel? What is the percentage of sand? What's the percentage of silts or clays? And based on the percentage, the one that has a higher percentage, we will use that letter for our symbol. Also, if we have a soil that has high content of organic material, we will use O, and if it's peat, we will use PT. So other options are O or PT. One of these will be selected to make the symbol for our soil. Now that we know what is the main component, if it's mostly gravel, sand, silt, or clay, now we need to use a second letter to describe properties of that material. So if it's a gravel, then we need to say if it's a well-graded gravel or if it's a poorly graded gravel. So if we have sand or gravel, then we can use W or P to describe if it's a well-graded gravel or if it's a poorly graded sand. We may also use M or C to say if it's a silty gravel or clayey sand. So again, this one shows what is the main component. Which one do we have more? If it's mainly coarse material or mainly fine material. If it's gravel or sand, silt or clay. And then the second letter is used to describe that gravel. So we have a sample that's mostly gravel, but it has 10% of fine. That fine is mostly silt. So our sample is silty gravel. Or if we have a sand sample, a coarse grain, mostly sand, and it has 2% fines, we can ignore a very low amount of fines, and then we need to describe our sample as a well-graded or poorly graded sand. If we have silt or clay, then we need to look at plasticity. If it's a silt with high plasticity or low plasticity, or if it's a clay with high or low plasticity. So for example, SW, the first letter means that it's mainly consisted of sand, and that sand is well graded. S and W. Or here we have GP. G, when we use it, means that soil is mainly gravel. And P means that it's poorly graded. So this is USCS classification. We want to go like in the next slides, we will go over the steps to come up with the symbol for our soil, for a soil sample that we have. In order to do that, so for USCS, we need results from sieve analysis and liquid limit and plastic limits. So we use sieve analysis and liquid limit and plastic limit results to come up with symbol for a soil sample. So in USCS soil classification system, question number 1 that we need to answer is if more than 50% of our soil, so we have a soil sample which is consisted of coarse material and fine material. The first thing that we need to look at for soil classification USCS is which one do we have more? Do we have more than 50% coarse material or more than 50% fine? That is question number 1, step number 1 for USCS soil classification. And in order to find this, to answer this question, we need to look at sieve number 200. Again, retained on number 200 is coarse material, and passing through sieve number 200 is fine grain soil. This is sieve number 200. Retained on sieve number 200 is coarse-grained soil. Passing through sieve number 200 is fine-grained soil. So, in order to answer question number 1, which one do we have more, coarse or fine-grained? We need to look at percentage passing from number 200. Percentage passing from sieve number 200, or as you see in this slide, we refer to it as percent finer than sieve number 200. They both mean the same thing, right? Percent passing from number 200 is equal to percent finer than sieve number 200. So if percentage passing or percent finer is less than 50%, less than 50% pass through sieve number 200 means that we have more than 50% retained on number 200, which means that we have coarse material. So if less than 50% is finer than sieve number 200, or then less than 50% of the material passed through sieve number 200, means that more than 50% is retained on sieve number 200, which means that more than half of our particles are coarse grained, so we refer to that as coarse grained soil. But if more than 50% passes through sieve number 200, or more than 50% is finer than sieve number 200, then it means that we have a fine grained soil. So question number 1, do we have more than 50% coarse or fine? In order to answer that, you need to look at percent passing from number 200. If more than 50% passing through or finer than number 200, we say that we have a fine grained soil. If less than 50% passes through, then we say that we have a coarse grained soil. Now that we have the answer to step 1, so we either have a coarse grained soil or a fine grained soil. If you have a coarse grained soil, then you need to follow the steps in this slide. So from step 1, this was step 1, we looked at sieve number 200. We said that less than 50% is finer than number 200, which means that we have a coarse grained soil. We already answered question number 1, or step number 1. Now we know that we have a coarse grained soil. So our step 2 is, which one do we have more, gravel or sand? That's question number 2. If we have a coarse grained soil. In order to answer this question, we calculate coarse fraction larger than sieve number 4. And if you remember, sieve number 4 has an opening of 4.75 millimeters. On top of number 4, we have gravel, and here we have sand. Sand is between number 4 and number 200. Fraction larger than number 4. Larger than number 4 means gravel. But we need to calculate percentage of gravel in our coarse section, not the total sample. The total sample is combination of gravel, sand, and fines. but we need to calculate percentage of gravel in our coarse fraction. That's what we call coarse fraction larger than number 4. Percent of gravel divided by percent of coarse material. If this number is larger than 50%, then we have gravel. If this number is equal or less than 50%, then we have mostly sand, and we will use letter S. So in step 2, for a coarse grained soil, we found our first letter. So either we have a sample that's mostly gravel or mostly sand. And that's step 2. In step 3, we need to describe our gravel or sand. So now we need to move to step 3. We have a coarse grained soil. Here, let's look at gravel first. That's mostly gravel, and we need to describe this gravel. It is important that we know how much fines we have in our coarse grained soil. If we have less than 5%, then you can say the amount of fine is very low and we can ignore that we have any fines in our soil sample. It's mainly gravel, fines is less than 5%. It's not important, we can ignore it. So now we need to see if it's a well-graded sample or if it's a poorly graded sample. And you remember these statements from sieve analysis. A well-graded gravel sample is a sample that has a coefficient of uniformity higher than 4 and a coefficient of curvature between 1, 2, 3. It's the same thing for sand. If we have a sand sample and we look at the percentage of fines, and if it's less than 5%, then we can say again the amount of fine is very low. We can ignore that there is fine in our sand sample. So what is important for us is to know if our sand is well graded or if it's poorly graded. But again, that's for when we have less than 5% fines. And this is from sieve analysis lecture. For a sand sample, a well-graded sample is a sample that has a coefficient of uniformity equal to higher than 6 and a coefficient of curvature between 1, 2, 3. What happens if the amount of fine is more than 12%? So we have a sample that is mainly gravel, but we have more than 12% fines. Then it's important for us to know if the fines that we have is clay or if it's silt. Same thing here for sand. If the amount of fines is more than 12%, it's important that we know what type of fines we have. So we will use what is called plasticity chart, which I will show to you later. And using the plasticity chart, we figure out if we have clay or silt. And then we have silty, sand, or clay sand, or a combination of both. Same thing here. We will use plasticity chart to see if the fines that we have in our gravel is mostly clay or silt, and then we can come up with a symbol, silty gravel or clayey gravel. And then, oh, if the percentage of fine is between 5 to 12, then we have to do both of these. We have a dual symbol. First, you need to figure out if it's well graded or poorly graded. Then you need to also see if the fines that we have is mostly clay or silt, and do a dual symbol. Same thing here. We do the well graded or poorly graded, and we do the silt or clay identification, and we come up with a dual symbol. Now, in this slide, from step one, question number one, we determined that more than 50% is passing through number 200. So more than 50% is fine. We classify that soil as a fine grained soil. That is from step number one. If that is the answer to question number one, which one do we have more, coarse or fine? And our answer is fine. Then we have a fine grained soil. Now our next step, or step two, is to look at liquid limit. Because again, when we have fine grained soil, what is important for us is plasticity. If we have material with high plasticity or low plasticity. So you need to run liquid limit and plastic limit tests on materials passing from sieve number 40. And then look at your liquid limit. If liquid limit is less than 50%, we have low plasticity and we will use letter L. If liquid limit is higher than 50%, we have high plasticity and we will use letter H. That's step two. If we have a low plasticity material, then you need to use plasticity chart. Using plasticity chart, you come up with the final symbol. So we will go over this later. But here you need to use plasticity chart. You find your point to see if it's above A line or below A line, or if it's in the hatched zone, and then you come up with your final symbol. Same thing for high plasticity. Again, you have to use plasticity chart, use your findings from liquid limit and plastic limit, and plot your data and see if it's above A line or below A line, and then come up with your final symbol. This is an example of a plasticity chart. The blue line you see here is the A line, and the orange area that you see here is the hatched zone. So again, we have, this is the chart that we went over it earlier. This is the chart for coarse grained soil, and we have the sieve analysis results. Step one, you need to look at sieve number 200 and percent passing from sieve number 200. 0.4% is passing. 0.4, which means that percentage of fines is 0.4%. This is 0.4. which means that our coarse is 100 minus 0.4, so we have 99.6% coarse material. The answer to step 1. This is a step 1. We need to look at percent passing from number 200. Less than 50% is passing through, which means that we have a coarse material. So now that we know it's mostly coarse, we need to see how much gravel and how much sand we have and calculate what we call coarse fraction larger than number 4. Coarse fraction larger than number 4, which is how much gravel we have in our coarse section of our soil. Now you need to look at percent passing from number 4. We just calculated the percentage of coarse material is 99.6. For gravel, we need to look at sieve number 4. Percent passing from sieve number 4 is 76.7. So 100 minus 76.7 gives us how much gravel we have. 100 minus 76.7. So we have 23.3% gravel in 99.6% coarse. 23% of the 99% is gravel. So we divide 23.3 by 99.6 and multiply that number by 100. And we get 23.4%. So in the coarse section of this soil sample, 23% is gravel, the rest is sand. The coarse fraction larger than number 4 is 23%. It's less than 50%, so this one is satisfied, and therefore our sample is mainly sand. And since it's mainly sand, we need to go here. So this is our step 2. In a step 2, we calculated the coarse fraction larger than number 4, the amount of gravel in the coarse section of our soil. It's 23%. It's less than 50%, which means that sand, we have more sand compared to gravel. Now in step 3, again we need to look at percent passing from number 200. So our percent passing from number 200, or the percentage of fines in our soil, is 0.4, which is less than 5%. Again, this is a very low amount of fines, so we can say that less than 5% doesn't have any significant effect on the engineering properties of sand, so we can ignore that we have fines in our coarse-grained sand, and instead of looking at fine to see if it's silt or clay, it's better if we see our sand is well graded or poorly graded. And in order to do that, you need to know what is CU and CC. So, for example, if for this sample we do the calculation and CU is 7 and CC is 1.8, then both of these are satisfied, and we can say our soil is a well graded sand, and the final symbol for this soil is SW. This is the plasticity chart which I mentioned earlier. It shows plasticity index versus liquid limit. A line is the blue line you see here, and the hatched area is the orange section of this chart. Let's go over the steps of USCS for coarse-grained soil. Question number 1, which one do we have more, coarse or fine? In order to answer this question, you need to look at percent passing from sieve number 200 and answer the question. Less than 50% finer than sieve number 200? If the answer is yes, you have a coarse-grained soil. If the answer is no, you have a fine-grained soil. Then you need to calculate coarse fraction larger than number 4, which is percentage of gravel divided by percentage of coarse material times 100. More than 50% of coarse fraction is larger than number 4? Yes, we have more gravel compared to sand. No, it's mostly sand. Then if the answer is gravel, then you use this table. One more time, you need to look at percent passing from number 200. That is how much fines we have. If the amount of fines or percentage passing from number 200 is less than 5%, we have clean gravel. So it's either well graded or poorly graded. Less than 5%. If it's more than 12%, then it's gravels with fines. We have too much fines to ignore. So we need to know if the fines we have in our gravel, if it's clay or if it's silts. And if the number is between these two, then you need to do both of these. It's a dual symbol. If the answer from step 2 was sand, then you need to look at another table. So for gravel, clean gravel, we said that clean gravel means that less than 5% fines, then the sample is either well graded or poorly graded. These are the statements that you need to check. If the amount of fines is more than 12%, then it's important that we know if it's clay or silt. Which one do we have? You have to use plasticity chart. PI less than 4, or your point plots below A line, the blue line in the plasticity chart. If one of these is satisfied, then the material that we have is silt. But if PI is higher than 7 and plots on or above A line, then the material is clay. Now, if we have sand, again, less than 5%, clean sand, well graded or poorly graded. More than 12%, sand with fine, clay or silt. And if it's between 5 to 12, you need to do both of these checks. So if you have clean sand, which is when we have less than 5% fines, then well graded or poorly graded, and these are the statements that you need to use. If we have more than 12% fines, then it's important that we know if it's silt or clay. You have to use plasticity chart. If pi less than 4 or your point plots below a line, then we have silt and we call that sample silty sand. If pi is higher than 7 and it plots on or above a line, then we have clayey sand. Let's go over one example. A sample of soil was tested in laboratory with the following results. It's a non-plastic for liquid limit and plastic limit, and the sieve analysis results are provided in this slide. Step number 1, we need to look at percent passing or percent finer than sieve number 200. Percent passing from sieve number 200 is 2%. Is it less than 50? Yes. The answer to the question is yes, which means that we have a coarse grain soil. Now we need to know which one do we have more in our coarse section of the material. Do we have more gravel or sand? You need to calculate coarse fraction larger than number 4. Again, this is basically how much gravel we have in our coarse material. Gravel is 100% minus percentage passing from number 4. Coarse is 100% minus percentage passing from sieve number 200. So it's 100 minus 48 divided by 100 minus 2 times 100, which gives us 53.1%. More than 50% of coarse fraction is larger than number 4? Yes, 53% of coarse fraction is larger than number 4. So the answer is yes, which means that the sample is mostly gravel. We have more gravel compared to sand. So the first letter is G for gravel. Now we need to find the second letter to describe our gravel. So we need to go back to percent passing from number 200, which was 2%, which is less than 5. And it means that we have clean gravel. So we need to see if it's well graded or poorly graded. Again, the amount of fines is small, it's very low, so it doesn't have a significant effect on engineering properties. It's more important to know if the sample is well graded or poorly graded. This is the table that you need to use for a gravel sample. We have the results from sieve analysis. We find D60, D30, and D10. And then you can calculate coefficient of uniformity as D60 divided by D10 and coefficient of curvature as D30 to the power of 2 divided by D60 times D10. So this is our coefficient of uniformity. This is our coefficient of curvature. Coefficient of uniformity is greater than 4. This one is satisfied. Coefficient of curvature is between 1 and 3. This one is also satisfied. We can say that we have a well-graded gravel sample. Let's go over another example. The results from sieve analysis, liquid limit, and plastic limit are provided. Again, in step 1, we need to look at percent passing from number 200. Percent passing from number 200 is actually how much fines we have. So we have 15.2% fines, which is less than 50%. So we can say we have a coarse grained soil. And if you actually calculate the amount of coarse material, it's 100 minus 15.2. So the amount of coarse is 84.8%. Less than 50% finer than number 200? Yes. So we have a coarse grained soil. Now we need to calculate coarse fraction that is larger than sieve number 4, which is again percent of gravel divided by percent of coarse. And here you need to look at percent passing from number 4 and number 200. So we have 100 minus 76.5 divided by 100 minus 15.2 times 100, which gives you 27.7%. Is this more than 50? No. This means that the amount of sand is more than gravel. So we have sand and we need to describe our sand. Now we again go back to percent passing from number 200, which was 15.2%. And now we know that it's more than 12%. So it's a high fines content. We need to know if it's mostly clay or silt. And in order to do that, you need to use plasticity chart. This is plasticity chart. We have the results from liquid limit and plastic limit tests. Liquid limit is 30. That's our liquid limit. Plasticity index. Plasticity index is liquid limit minus plastic limit. So 30% minus 12%, which gives us 18%. So you see that our point plots above A line. A line is the blue line that you see here. This blue line that you see in the plasticity chart is called A line. And our data point with a liquid limit of 30% and a plasticity index of 18% plots or is placed above the A line. So it's not below A line, it's above A line. This one is satisfied. And PI is 18, which is above 7, which means that Our sample is clay sand.